Hello and welcome back to our journey through this solar system. Today we are visiting our first dwarf planet, Ceres. Now Ceres is named after the Roman goddess of agriculture, whose Greek counterpart was the goddess Demeter. Ceres is one of 5 dwarf planets recognized by the IAU, and its minor planet designation is a 1, indicating it was the first asteroid ever discovered, but we'll get more to that later. Ceres is the smallest of the dwarf planets, but it's still large enough to have become spherical under its own gravity, one of the requirements to be considered a dwarf planet. It is the only dwarf planet in the inner solar system, being located in the asteroid belt in between Mars and Jupiter. In fact, Ceres makes up a quarter to a third of the mass of the entire asteroid belt. Even so, its mass is only about 10 to the 21 kilograms, or a little more than 1% the mass of our own moon. It's pretty small. Spatially speaking, it has a diameter of just under 1,000 kilometers, meaning that the surface area of this entire dwarf planet would be the 9th largest country on Earth by surface area, coming in just behind Argentina and just ahead of Kazakhstan. Like I said, Ceres is located between Mars and Jupiter, so it's a little less than 3 times farther away from the Sun than the Earth is, giving it a year that's a bit over 4.5 Earth years. Not surprisingly, at that distance, it's pretty chilly. It has a mean surface temperature of only 168 Kelvin, which is a whopping negative 150 Fahrenheit or so. It has a relatively mild axial tilt, currently about 4 degrees, which means that it does have these permanently shadowed areas and craters near its poles, which allows these cold traps which kind of collect water ice. We see a similar thing on Mercury and the Moon. Now I say currently 4 degrees because thanks to the influence of the giant planets, Jupiter and Saturn, Ceres actually isn't stable in its axial tilt, so it tends to vary over time, and it can get as high as 20 degrees or so. And in fact, that probably happened about 14,000 years ago, so relatively recently, astronomically speaking. Ceres is a partially differentiated body, which means that it has distinct layers of its composition. It's not just one lump of rock like maybe a smaller asteroid might be. Being so cold, Ceres is composed primarily of ice, and one of the most interesting things about Ceres is just how much water it contains. Ceres is almost 50% water by volume. Compare that with the Earth, which is only 0.1% water by volume. So you'll see Ceres is very water rich. And in fact, the material in it is called muddy because it's a mixture of rock and water. Now, the exact interior composition of Ceres isn't well known, but some of the prominent models suggest either 2 or 3 main layers, and not sure about the existence of a very small metallic core underneath those. In any case, it definitely has a crust and a mantle that are not quite the same, which scientists can know based on basically how the crust reacts to impacts and how it looks, based on its Now, the exact interior composition and structure of Ceres isn't really known, but prominent models suggest either 2 or 3 layers, and it's unclear whether or not there might also be a small metallic core at the very center. But there's definitely a crust and a mantle at least, and they don't seem to behave exactly the same based on the way the surface impacts and changes. Now, unsurprisingly, given its very small nature, Ceres does not have an atmosphere, but it does have what is called an exosphere. Now, this is kind of a very tenuous and transient atmosphere that's caused by water ice sublimating into water vapor that then kind of lingers before it gets lost to space. Now, Ceres falls into this kind of strange size regime where it's a very large small body, but a very small large body. And that's because it is one of the leftover protoplanets from the very early days of the solar system. And most protoplanets didn't stick around. They either went on to merge and become planets, or they were just got ejected from the system. But that didn't happen to Ceres, and so we can actually peer back in time and look at the early composition of the solar system by looking at Ceres. And one thing that's interesting about that is that while Ceres is currently in the asteroid belt, it doesn't seem to have formed there. Based on its composition, scientists think it probably formed in the outer solar system as a centaur, and then got moved into this current location. So it's just more evidence for some of this early churning of the solar system that we've talked about a little bit, especially in the Jupiter video, that Jupiter probably moved around quite a bit, and being the most massive planet by quite a lot, that caused a lot of ripple effects in the structure of the early solar system. Now, Ceres has a very high water content, and it actually has a geologically active past. Now, this is thanks to leftover heat from its formation, as well as heat from radioactive decay of some of its constituents. And this means that Ceres might actually have been able to maintain a subsurface of liquid water. And so, in fact, Ceres is one of the places that extraterrestrial microbes might exist in the solar system. That's a big might. And if you've watched or read The Expanse, you know that Ceres makes a great outpost to begin the colonization of the solar system, especially if you can get Tycho Manufacturing to spin it up. Now, despite its relative proximity to Earth, Ceres is actually just too small to be seen by the naked eye. You need a telescope, but not a very strong one. Now, it was first discovered in 1801 by Sicilian priest Giuseppe Piazzi. At the time, astronomers were actually searching in that very location for a planet due to the kind of gap in the spacing between Mars and Jupiter. The infamous Bode's law predicted that there would be a planet there, and so Bode, among others, was searching for this planet. But Piazzi actually found it by accident because he was looking for a star, and he noticed this kind of moving object, and so he thought it might be a comet, but he also noticed it wasn't quite like a typical comet. So he said it was a comet or possibly something better. Piazzi was in fact the one who proposed naming this planet Ceres after the goddess who made her earthly home in Sicily, where he was from. Now, all of the major planets have astronomical symbols, which I have been showing at the beginning of the videos so far in this series. Now, Ceres, based on its discovery and basically not knowing what it was, actually did have its own astronomical symbol as well. It was a sickle, based on a sickle, which makes sense because Ceres, like I said, was the goddess of agriculture. However, as more and more of these very small bodies began to be discovered, it became too many symbols to keep track of, basically. And so in 1851, there was a new system proposed to basically just give them symbols of numbers in the order in which they were discovered. And Ceres, being the first asteroid discovered, has the minor planet designation of 1, and so technically its astronomical symbol is 1 inside a circle. Now, this classification of Ceres is really interesting because it kind of has changed a lot over the 200 years that we've known about it. So when it was first discovered, like I said, Piazzi thought it might be a comet, maybe something better, aka a planet. And some of these astronomers, especially in the first half of the 19th century, did think that Ceres was a planet, and it was considered one of the planets for a while. But then as more and more of these small bodies began to be discovered, it started to seem like, no, maybe this isn't actually a planet. And in 1802, only a year after the discovery of Ceres, this new term called asteroid was developed. And this term means star-like because even though these objects seemed to move and were clearly part of the solar system, they really appeared like stars even in a telescope. That means scientists couldn't resolve the shape of them because asteroids are so small. So sometime in the second half of the 19th century, when there's all these new asteroids being discovered and Ceres was, known to be quite small, it wasn't really considered a planet anymore. But there wasn't a formal definition that was, clarifying what was a planet, what was an asteroid, or anything like that. That didn't happen until 2006. Which was, of course, the infamous decision by the IAU. Now, one of the original proposals to the IAU for the definition of a planet would have actually included Ceres because it would have just required it to be something that was massive enough to become spherical under its own self-gravity and not be a satellite of another object or not be a star. So if that definition had been accepted, Ceres and all the other dwarf planets would have been considered planets. However, another requirement was added that the body must clear the neighborhood of its own orbit, which Ceres definitely doesn't do. Like I said, it's part of the asteroid belt, so it shares its orbit with thousands of other small bodies. And so this is why Ceres is not a planet, but it did become considered a dwarf planet based on this decision by the IAU. And like I said, there are only 5 dwarf planets recognized by the IAU. Interestingly, it's actually not entirely clear whether or not Ceres is still also considered an asteroid. You might see this both ways in literature, and it's possible that Ceres could be considered both an asteroid and a dwarf planet. They don't have to be conflicting designations, but some people consider that the dwarf planet classification kind of supplanted the asteroid classification. So you'll see it both ways. Now, starting with Piazzi in 1801, we've done a lot of excellent remote observations of Ceres, including some high-resolution images from the Hubble Space Telescope and the discovery from the Herschel Space Telescope about the water vapor exosphere that I was mentioning earlier. But even better, we've gotten up close and personal with Ceres. So as part of NASA's Discovery program, the Dawn spacecraft launched in 2007 with the goal of visiting Vesta, another asteroid, and Ceres. Dawn visited Vesta first, and then it went to Ceres, and so it entered Siberian orbit in 2015, and it lasted on its mission there until 2018 when it ran out of fuel. And in fact, it's still in its stable orbit around Ceres, it just doesn't have any fuel left. And it's carrying on board, interestingly, a microchip that contains the names of 360,000 space enthusiasts. This was part of an outreach project NASA did. And so it's kind of a monument sitting there in orbit around Ceres, including the names of all of these people, which I think is really cool. As it orbited Ceres, Dawn gathered a lot of excellent information about the shape and the surface topology, the mineralogy, the specific gravity field of Ceres, all sorts of excellent stuff. One really important thing that Don revealed was these so-called bright spots located in the craters on Ceres. Now, this actually later turned out to be salt deposits, and Don also discovered the presence of ammonia on Ceres. And ammonia on Ceres is the reason that scientists think it didn't form in its current location, because ammonia is generally found in the outer solar system. And so this was a really interesting discovery from the Dawn spacecraft. So Ceres is an amazing little dwarf planet, or big asteroid, or both, a remnant left over from billions of years ago in the very early solar system, and the only dwarf planet this side of Neptune. So thank you so much for coming with me to Ceres today, and I hope you will join us as we venture on to the next dwarf planet next time. All right, thanks for watching. Have a good one. Bye.